This question is the most asked question in an interview for a Solidity developer, for a DeFi developer, for a DeFi protocol developer. Mainly when you will start applying for a job in a DeFi organization which deal with the financial system of the blockchain. So this is the very common question you will be asked about the use of math library inside the function, that how it's prevent and what kind of role it's play in the contract. Because you know that when we perform any transaction on the blockchain, we perform some sort of mathematical calculation, whether we are transferring token or whether we are transferring fund from one account to another. We have to do some sort of mathematical calculation inside the contract to prevent a lot of vulnerability. So this is the simple question I have. So the question is, in Solidity, developer often use the SafeMath library to migrate the risks associated with the arithmetical operation in the smart contract. So this is the first part of this particular question, that we use some sort of arithmetical operations, whether it's divide, subtraction. I'll talk about a specific function they have mentioned in this particular question, but we perform some sort of calculation to avoid the risks in the contract. So the second part is, suppose you are working on a project involve handling token balance and transaction. So first part is arithmetical operation. Second part is as a new developer who working on a transactional contract which deal with the balance and transfer of the fund. That's the second part. The third part is discuss the significance of incorporating the SafeMath library and provide an example scenario where the absence of the SafeMath could lead to vulnerability in the smart contract. So this is the third part of this question. What is saying that what is the impact of SafeMath library in the contract, and if you not include that, what kind of problem it can create. So here the interviewer is testing your knowledge, your understanding about the SafeMath library and how well you know about this particular library. Additionally, explain how the SafeMath library help address these concerns and maintain the integrity of the contract. Can you outline the specific functionality of the add function in the SafeMath, that why it is essential for ensure smart contract development? As you all know that in SafeMath library we have multiple functions, but here in this particular function they have highlighted that you have to focus on the add function. You have to focus on this and you have to build a smart contract which will deal with preventing the vulnerability, and if you not utilize it, this vulnerability will exist in the contract. So first thing is that when you will sit for an interview, you have to break down the entire question. The candidate, they don't understand the question, that what the interviewer asking them to do exactly. You can bring the functionality, but you have to build the functionality based on the question requirement. So the first thing is that we have understood our question. We have to use this add function. We have to explain the, if we use it, how we can prevent the contract, and if we don't use it, then what kind of problem we're going to face it. So here we have to build a one contract which have two different phases. One in which we're going to include the functionality of this add math, and in the other one we have to simply avoid it. Let's try to understand the most important point of this particular question, that what are the things we have to keep in mind when we write the actual smart contract using this functionality, using this SafeMath library. So it has 4 points: revert on overflow, preventing overflow and underflow, security best practices, and functionality. So these are the entire scenario on which your entire contract is going to be focused on. So let's try to write the smart contract and let's do all the testing, all the things which we have learned as per the question. So here I have taken my license identifier and Solidity versions. I'm using this particular version because in that we can easily able to see the overflow and underflow, and most of the contract which you're going to deal on a DeFi organization which are deployed like 2 years old, 3 years old. So they are already in the previous version. So we have to know how we can interact with those particular contract and get more information and build on top of that Solidity version and this license identifier. So first thing, I'm going to write my library contract, and this is the library contract which I have built for this particular SafeMath. So it can have multiple function, but here we are dealing with only add function because that's what we have mentioned in the question. So this is how our add function is going to look like, and this is how we have to define the library. So they have called it to build a library. We have to give a name to SafeMath, and in that we have to build a functionality called add function. So this function is pretty simple, although it's going to be an internal function. That's why we have used pure. You can make it public and you can call its return. So it's going to return the third variable, which is unt 256. We are simply adding those two number and storing as a C variable, and then we are checking this condition. And here we are simply doing the comparison. If C is greater or equal to A, then we have to simply execute. Otherwise, we have to simply throw an error message, because if A is 2 and B is 1, if we add up to C, this C will become 3. And if we compare with the A, obviously it's a true statement that this one is greater, then it will pass and going to return the C value. So this is the simple function we have for add in safe library. It will take two number, it's going to add those number and it's going to return the C number. So this is our library. Now let's write the contract where we can display that how we can utilize this particular library in our contract function to perform some mathematical operations. So here I have written a smart contract. I call it add contract, and I'm using the same library. I call this use, means I'm referring to this, and I'm called the SafeMath this, and I'm using this for a UNT because that's what is going to return. And here we have this particular function inside this add contract. I have called this save add. It will take two number. Again, it's a public pure return and it's going to return a UNT variable, and that's what we are simply calling here. So we are calling this X and we are simply calling this particular function. In that we are simply passing this. And now let's write the another contract which is going to deal with without this particular library. So let me write that one. And here I have written another smart contract which deal with the overflow without add. And here I have taken a variable like UNT balance, and here I have given this comment maximum representable UNT to 50x value. So you cannot go with more than this, otherwise it's going to create an overflow. So here I have this function in that I have called the save add. I'm passing X and I'm going to return this balance, new balance. So what I'm doing, I'm taking the balance and adding X and it's going to return, and this will create an overflow. So let's come back here and let's try to deploy the contract. So first thing I'm going to do is I'm going to deploy this particular one called add contract, and hit enter. Let me bring it up so I can show you. I can click on this deploy, and here the contract is deployed. Simply ignore this one. And here we have this deployed contract. If I open that, you can able to see that I have this particular function. So this is the function which I am calling save add. All I have to do is to simply pass the two number. So if I pass 5 and if I pass 7, can you guess what exactly output I will receive here? So let's call this one. I hope you guys have guessed. I will get 12. I'll get it 12. Because what it's doing when I'm calling this particular function is passing these two variables right up in here, and it's comparing that this is one is 5, this one is 7. So it's add up to 12, and here we are checking that C is greater than 5. Yes, then we have to simply return the C, and that's what we are doing here. So this is how we can incorporate mathematical operation in the contract using the save library. The first thing is done. Now let's try to do something with this and see what exactly problem we'll face here. So now come back here, let's change the contract and go to out, add and deploy. The contract is deployed. Let me do this one, and here we have, click on this, and here we have this function. In that, all I have to do is to pass the X. That's what I'm passing, and that's what I'm returning here. So if I pass any value, if I pass at least 1, it's going to create a problem because I cannot go with this maximum value. So if I take, like, let's say 2 or any number, if I click on this call, it's going to throw an error. It says 0 because here we are having an overflow. So when there is an overflow occur, the value will return back to the 0. So let me expand this one, and you can see here we have this. I have passed this one, and here it's went down to 0. But we have this particular number. Let me show you one more time. What I'm going to do is I'm going to remove this one, and I'm going to copy, and that's what I'm going to simply return here. So you will see we have a big UNT variable. So let's deploy one more time. Click on this add, and it's going to deploy the contract. Let me say okay, and here I have the contract. Now if I call this, no matter, it's an optional one. If I call this save add, it's going to return me this particular variable. Can you see how big problem it is if you don't handle this overflow and underflow? If a user have this much fund in his account, and we have a 256 integer value, if it exists by only 1 or 0.1, it's going to simply deduct the entire fund to 0. That's a huge problem. I hope you guys can understand that. So let me show you. Let me take this one value. I'm going to take this one. This one is really very dangerous in the smart contract, and that's the fundamental interview want to test you. So which contract I have deployed? Not this one. If I take this one, go to the without, and here if I simply deploy the contract, here we have this one. Now let me open this one, and let's pass that one variable. If I pass at least one, is going to make it to 0. But we have a lot of fun, but it went down to 0. So I hope you guys have understood that what exactly happening here, how important this, to keep in mind that the maximum representable number in Solidity smart contract is this. So if it goes beyond at least 1, it will went down to 0. So that's why we use this kind of SafeMath library. It doesn't matter how big number. So that's the problem we have when you will not use the save library. But if you use the save library, it's going to do always proper transaction. No matter user how big number it will put, it's going to add up and it's going to return the C, which is always will be greater. And that's how we can simply prevent an overflow, and we can detach that whether the variables we have attached is the like UNT256 is greater or lower. So let's test that out. I can show you that as well. So like if I come back here, this is the maximum representable number we have. So let me simply copy this one, and I can simply, let's deploy the one more time. So I can simply copy that, paste here, simply click on this deploy. The contract is deployed. Now I can simply click here, and if I pass any number, it doesn't matter, it's going to give me this big number. I can simply take this number, copy this one. I can simply come back here. Let's try to deploy the next contract called add deploy. Here the contract deploy. Now I can come back here, open this up. I can simply paste this as a true number. So this one is my A, and this one is going to be, let's say, 5. If I click on this, the transaction will fail because that's creating an overflow, and that's how we can prevent any kind of error in our contract to take in place, because here we have simply identified the overflow, and that's working absolutely fine. So hope you guys have understood that what exactly happening here, how we are preventing an overflow in our contract, what kind of problem is going to create when you will not use the save library to detach whether it's overflow or underflow. So this particular add function we use for only overflow, and here we have this, the contract which caused the overflow and throw an error, and it's drained the entire fund of the user. So this one is very important. This is a very important question. I want you to familiarize yourself and try to understand that what exactly happened. There is a lot of function we have in this SafeMath library, which we can utilize to build the functionality to prevent different kind of overflow, underflow, or error. So those are the things. Again, this entire video and the source code is already given. So you can come back to this Solidity interview questions. I'm going to attach all the question one by one. So this is the very first one, and I'm going to attach this particular video as well here. So you can simply click and you can download all the material. Or if you want to master the blockchain development with project and learn every single thing in the higher level, including the smart contract development, Solidity course, then you can check this one as. In this, we have built one of the biggest project which will teach you every single thing which you have to know to become a Solidity smart contract developer and a blockchain developer. So with that, I'm ending this. In the next video, we're going to see a different questions, and we're going to solve all the problems and try to understand that what interviewer exactly asking you to do and build the contract. Because most of the time, the student don't understand the question, and that causes the problem for getting a job and internship. So that's the only thing from my end. Have a wonderful day. Bye-bye.